Good afternoon, everyone. I think we've got about 6 people coming in. My name is Ati from ClearCalcs. I'm just going to give everyone maybe a couple more minutes to come in. In the meantime, if you would like to drop your name, where you're tuning in from, your title and company in the chat, we would love to see who's in the room and just get to know each other.
I'm happy to start off. I'm Kyle from Aus Engineered. I'm tuning in from Melbourne today.
Yep, Kyle is our presenter today. And I am growth marketer from ClearCalcs, and I'm sure most of you have seen me or received an email from me at some point. Also, you're more than welcome to switch on your videos if you wish. Always nice to see ClearCalcs users and audience in the room. That we will get to have the session more interactively as well. A few more people coming in. Welcome, everybody. We're just doing introduction right now. If you want to drop your name, where you're tuning in from, as well as your company in the chat, we would love to know who you are and where you're tuning in from. We have myself. My name is Ati from ClearCalcs. I'll be hosting the webinar today, and we also have Kyle, who is our presenter.
What's the weather like in Perth, Ati?
Pretty chilly today. We've had a good run last week, 29, 30 degrees, but then it's getting cooler now.
Wow, 29 in May. That's pretty warm.
Yeah, I think they call it the hottest May in how many years? I can't remember. Yeah. All right. Good morning, Sebastian. Good to see you.
Good morning, everybody.
Good morning. Where are you tuning in from, Sebastian?
I'm from Perth.
All right. Okay. Good to see someone else from Perth. And what company are you from?
VTP Engineering.
Okay. Cool. Welcome.
Thank you.
All right. We might give it one more minute, Kyle, and then we'll kick off. All right, I think we'll kick off now. Let me know if you've got my screen. Welcome everyone to this webinar today, where we will be discussing how we are using ClearCalcs to add an additional living space for a loft renovation project. This webinar will be presented by Kyle. He will introduce himself shortly. I am sure like all of you are familiar with ClearCalcs. We want to help engineers work more efficiently and productively by bringing all your calculations on a cloud-based platform so that you can deliver more accurate and faster calculations for your clients. Just a quick one about today's webinar. You can always ask your questions or anything that you want to raise using the chat function. You'll see the chat function whether at the bottom of your webinar Zoom controls, or if you can't see them, click on the 3 dots on the right here and you should be able to see the chat functions. I will monitor the questions as they come in, and then we will use the last 15 minutes or so of the webinar to discuss the questions. We might invite you to ask the questions live so that you can ask your questions directly to Kyle. So if you're comfortable, just feel free to either show your video or unmute yourself to ask the questions later. All right. I will now hand over to Kyle to introduce himself and get started with the webinar. Kyle, I'll hand over the presentation to you and feel free to share the screen from your side.
Awesome. I'll start sharing my screen. Just give me one moment. Can you guys see my screen okay now?
Yep, I can see your screen.
Perfect. All right, let's do this. Oops. This one might be the better one. So thanks everyone for tuning in. As I said, yeah, my name's Kyle. I'm a project manager with Aus Engineered. So we've worked with ClearCalcs for about 18 months now. on a range of different sort of projects, and I've been using ClearCalcs. We've been using ClearCalcs at the company I work for about probably over a year now. And Atty sort of said, hey, why don't you share one of the projects you've used ClearCalcs on, and just go through the design procedure for that you've done, and it might be useful for other people. So enough about me. Let's get into the presentation. So for today's agenda, I'll start by sort of introducing the project. So a lot of the sort of a lot of people reach out, a lot of builders and a lot of clients reach out, and it's always about adding space, renovation projects. So whether they want to add a room, extend the property, add another story, knock out a wall to add more living space. It seems like, with population density and things like that, there's going to be a lot more sort of space addition projects coming up. And this particular project that we worked on was sort of a creative way to add space into a loft apartment, somewhere that it's, often quite tricky to add space to apartments. So we'll start off by just sort of introducing the projects and how we gathered the information to inform the design. Then we'll go through the design procedure for the members and connections. I'll just sort of describe the procedure we used, and how ClearCalcs was applied to sort of streamline that process for us. And then we'll go through the project deliverables, so the outputs that we provided to the builder and to the client that helped facilitate the project. So it's easiest just to show sort of a photo. So there's a 2-bedroom apartment in Melbourne CBD with 5.5 metre high ceiling. So it was part of a mixed use building. And we were engaged by the builder to provide engineering services for the loft conversion project. So basically to specify some beams, the connections, and essentially provide those services. So you can sort of see that the kitchen in here, the owner was interested in adding a mezzanine space above the kitchen. So where these downlights are, this sort of whole section of framing and plasterboard was just sort of redundant space. And they thought that they might be able to add in a little mezzanine space that was accessible via a ladder for storage, or just add space to the little apartment. So we were engaged by the builder quite early, so we were able to participate in sort of the concept design. And so there was also an architect on board and a town planner as well. So as a team, everyone on the team was involved in the concept design, which was really good. It usually leads to a successful project. And this was sort of the sketch that was sort of presented to the client about what they wanted to achieve. So adding in a proprietary system ladder and some framing to add, and a barrier, and ultimately achieve some storage space above the kitchen that they didn't previously have. So the next sort of part, once we sort of had sort of a concept of what the client wanted, was to assess the information available. Often with these renovation projects, it can be really difficult to get good quality information about the existing structure. So, often buildings, they're quite old and the record keeping on them isn't great. And that's the same for commercial buildings. Even though they're managed by body corporates, often they change. The building will be managed by different body corporates over its life. And the as-built drawings for the structure aren't often maintained very well. And often that can be a deal breaker for us when we take on a project like this, because there's inherently a lot of risk associated with, modifying an existing structure. So we engage the body corporate early to understand their requirement for private building works, because it does vary between body corporates. Often they'll have a sort of procedure and a list of requirements that they need the builder or the engineer or the architect to have to be able to make those modifications, and then they'll list a bunch of the documents they require for you to make modifications to that building. Fortunately, in this case, we were able to secure existing structural and architectural drawings from the body corporate, which were very informative in the design. I would also preface it by, it's always key to ensure that the drawings are verified on site and not relied on for complete accuracy. So even though if you have good quality as-built, it's always key to confirm the dimensions, condition of the existing structural components. So we were able to go digging and work out the span of the existing slab that the apartment was on, and as well as the vertical columns and supporting members, their orientation, and based on the as-built drawings, assign a capacity to the slab, and work out, is it even possible to add, additional loads to the slab from adding in an additional space. So once we had those drawings, we felt, and did some site investigation work, we felt quite confident in that we could achieve the project, which was good. Often, if in a case where we wouldn't have these drawings, there are other methods that you can do. You can go and conduct on-site measurements, look through the structural members, look through manholes. You can do non-destructive testing like scanning for reinforcement and things like that as well. I guess the challenge with those are that it's expensive, and often there's a lot of sunk cost that goes into those investigations, and it's possible that you can't even achieve what the client wants. So it's really important to keep them informed in the lead up to, if you are going down that path of, okay, we've got no drawings, we need to verify what these members are, and if there's sufficient capacity, to keep them informed that, we'll assign the capacity of the existing structure, but we can't guarantee that your renovation will be able to be facilitated. Because often, clients can get grumpy when you come back and say, here's the bill for all the investigation work, but sorry, we can't do your renovation. So it's just important to manage that relationship and be clear about the risks associated with any project. So it's important early as well, before you go and get tuck into the design, to consider council, shire, or planning laws. So because depending on the use case for the space being added, planning permits requirements can be triggered. Be sure to consult with the local council about the project and engage a town planner to assist with any required planning applications. We don't do any town planning ourselves. We leave that for the experts, and ensure that we ensure that they're engaged for the project when we feel they're required, in consultation with the builder and the client. So and often adding storage space such as non-habitable rooms, they can be exempt from planning permits depending on where they are, but the loads required for storage calculation as per AS 1170 are often much greater than general use spaces. So that's just some important things to consider depending on the use case of the space. So once there was confidence that was sufficient structural capacity that the planning laws would permit the construction, a qualified architect was engaged to draw up some plans. And we received these draft copies of what beams and columns required specifications by the engineer. So then in terms of, going into the actual design procedure for the members, determine the loading requirements, which stems from the use case of the space, which is quite easy, just using AS 1170.1. And then we jumped into designing the primary beams first. So we did that using the tributary width of the new mezzanine area and calculating the load that would be attributable to the new primary beam for the new space. And that was, allowed us to specify the loads into this ClearCalcs steel beam calculator, and which was then used to find the most structurally efficient member. I'm happy to show you our ClearCalcs output. Just to note, there is a link down the bottom of these slides that will be sent around that goes into detail the design procedure for steel beams for each member that we talk about. I'm not going to cover each of them in detail just due to time, but yeah, those links are pretty useful. They're being prepared by ClearCalcs, so they're very good to follow. So I'll just jump in. So this was our project that we created. We had the address in, the client, and then we have all of our calculators in here that help us design these members much more efficiently. So the member in question was the primary steel beam, or B1/B2. And we were able to come straight in, input the dimensions from the drawings. We were able to input the dimensions of the beam that was required. So in terms of span, the length of bearing that the beam would have, and also provide input the loads that were determined according to the AS 1170.1. We could also put in the tributary width of these loads, which is really convenient rather than performing all those hand calculations for those distributed loads, and also add in point and moment loads, as well as the beam orientation. So quite easy to input. Spits out a nice little diagram here that shows what loads are applied to the beam. And then we also go through and check all the other parameters for the beam calculation. Most of them can be left as default if you set up your project defaults according to Australian standards. But it's important just to check each of them and ensure that they are suitable for this beam. And what we really like is with ClearCalcs is you put all the inputs in and you get instant feedback sort of through the traffic lights. So depending on the utilization of the beam under the loads input, you'll get a green for the beam's adequate, orange if it's close to nearing utilization, or red if it's overutilization. And then you can go through and change parameters, and it'll instantly update the utilization percentages via the traffic light system. And that's we find that really fast. If I go through to the secondary beam, so the reason we designed the primary beam first was because in order to achieve the vision of the client wanted the secondary beams to bear on the bottom flange of the universal primary beam, and sort of sit in between, essentially sit flush up against the web and bear on that bottom flange. This was for a few reasons. One, for aesthetics, and also two, they didn't want too much of a reduction in ceiling height. So that was why the primary beam was designed first. And once that was sized, we knew that the secondary beam couldn't have a depth greater than 200 millimeters to ensure that we could fit it in the flange of the primary beam B1. So I'll jump into the ClearCalcs. Sorry. Just look through here. So this was for the secondary beam design, which was a timber beam. Again, we went through and input all the loading conditions for this beam, and the tributary width of each, the tributary width of that loading. Using the ClearCalcs member selector tool, which we find to be really useful, we're able to select from a range of different manufacturers, stress grades, and specify some maximum depths and widths for the member. And that really came in handy here. So when we are engaged by a builder, we'll always ask the builder, do you have a preference on the timber or steel for the beam? Do you have a preference on manufacturer? And often they do, because they'll have existing relationships with suppliers. They might get discounts through a certain supplier for a certain product, or it might just be a preference because it's they're able to procure it close to site. So we're, straight away we're able to filter on a range of manufacturers of Australian timber beams, which is fantastic. The builder said that they were interested in using a member from Hine, and we knew that we needed a glue lam member. So we went for just by inputting some filters, we were able to come up with, a suitable design. Just back to what I was saying about the secondary beam needing to fit into the web of the primary beam. You can see here that we're able to, specify a max depth of 200 millimeters, and that automatically filtered on beams that would be suitable dimensions to achieve that connection. And then you get, instantaneous feedback about what members are going to be suitable, which member is going to be suitable for, and what utilizations it achieves. So you can, ensure that you achieve both an efficient design, but also a safe design. And if we were doing this through, Excel spreadsheets or something like that, it would take, takes a lot of time, because you need to input the dimensions for each beam and the section properties for each beam. Trial that. Oh, that one doesn't work. You'll trial another one. Whereas this, you can get the most efficient member really fast, and you're able to make design changes quite quickly. Whether it might be the length of bearing area that you might want to change. It could be the center to center spacing that you might want to change. You might want to change that to 300 because due to certain site constraints, or 500, and you'll be able to get instant feedback on the the result of those changes. So it enables you to be sort of really efficient, both in time and structurally efficient in the design. Keep going. There's, again, link down the bottom of that slide for the design procedure. So for the design of the steel columns, again, we had some section constraints. So we needed to attach the primary beams to the columns, and as a result of the primary being the size that was specified, we had to ensure that the column had a flange that was sufficient, of a sufficient width for that connection. So if we just jump back into ClearCalcs, just load. Yep, perfect. So we were able to, again, in the member selector tool, you're able to specify the max depths and widths of sections, any grading, and the dimensions. So we were interested in a square hollow section to achieve this connection, but there's a range of other sections that could have been used, but just to achieve the constructible connection, we went for the square hollow section. You obviously get the traffic light capacity feedback right away because of the dimensions we required for the column to achieve the connection. We ended up with a fairly structurally inefficient member, but one that was easily constructible on site, a connection that's easily constructible on site. So that was good. And then another feature that is quite good with ClearCalcs is you can link loads. So you could see we've got our other beams in here that are going to be passing load through to the column, and you're able to link those beams to the column, and to ensure that the column is picking up the loads from those beams, rather than performing heaps of calculations by hand or using spreadsheets. So that's definitely a big time saver. In terms of the design of the connection, this is sort of what I was talking about with the connection where we had the timber beam bearing on the sort of slotted into the web of the primary beam, and the connection that we were trying to achieve there. So not a sort of standard connection that would go for, but one that would result in the least reduction in ceiling height, which was obviously a key specification from the client. So based on this sort of concept for the connection design, we're again able to use ClearCalcs. Sorry if I just get out of that. Just go and show you in ClearCalcs. We were able to verify that the bolt sizes specified would be sufficient, and that the weld sizes would be sufficient as well. And that, that is a real big time saver for us, just being able to verify those bolts and the length of the weld and the type of the weld and the thickness of the fillet of the weld. Just really fast, punch it into ClearCalcs and get an instant response. Standards are updating all the time, and so we found that often the spreadsheets that we were using for our designs would become out of date quite quickly, and so whoops, gone for that one again. So often the spreadsheets we would use, they'd become out of date quite quickly, whereas ClearCalcs gets updated with each revision of Australian standards, which and we can feel confident in our design that we are in accordance with the latest standards, and not having to sort of back calculate sort of changes into any Excel spreadsheets or anything like that. So again, we had 3 connections to design. So there was the steel beam, the timber beam to the steel beam. Then we had the steel beam to the column, and then we had the connection into the existing slab, which was designed using a manufacturer's proprietary product, and it's essentially true bolts, and using their design calculator for that one. So jumping to the next step, we had our drafting. So once we were able to specify the beam sizes, spacings, and connection details, we were able to sort of update the drawings for the drafter to ultimately reflect on the final drawings, specify some general notes for construction, a key one being verify the as-builts on site, because the whole design is contingent on assumptions in those. We jumped to our project deliverables. So being the structural engineer, we issued structural drawings, Form 126, and the structural calculations, which were exported neatly formatted from ClearCalcs. So I'll just show that step, because that's really key step for us. In Victoria, we're required to provide this Form 126 and the calculations as part of the design to ensure compliance. And often that, having to submit calculations can be tricky, and it's tough to neatly format them in a way that's usable. But using the export tool in ClearCalcs, you can automatically export. I usually go for detailed, because it gives every single design assumption detailed. You can export all the calculations, and it really walks through the method for each of those. Usually chuck it in A4. It will talk about the project defaults. It'll give a member schedule summary that can be useful for the builder when they're ordering materials. It just summarizes what members are used, and then obviously all the detail for each separate calculation exported either in PDF or Excel, which is again a massive time saver rather than having to type up calculations for that requirement. So there's a little sort of snip of part of the report that was exported. It has the beam name, it details the Australian standard reference, and then walks through the calculations that the ClearCalcs calculator has used to determine that member to be adequate. And that's really useful as well to give to the client in future. They might want to make additional changes to the structure in future, and if they've got that handy, they can provide that to the next engineer, and that can greatly save them time as well. So it's a really great feature. That's all for the presentation. Did anyone have any questions?
Very nice, short and sharp overview, Kyle. Thanks for that. If anyone has any questions, feel free either to just unmute yourself and say hi, and then we can discuss that interactively. Otherwise, feel free to drop in your questions in the chat as well. While we do that, Kyle, curious to know, from the moment when you receive this design request until the deliverables, how long does a renovation project like this take?
Yeah, so this one, in terms of the actual design, once we had all the information available, we were able to produce a design in about a week. But the thing that really extended that time out was getting all the right information. So often when you are trying to procure as-built drawings, for example, that can be really tricky. Often the owner of the building isn't sure. That they don't think they're important or don't have them if the building's old. You could be dealing with body corporates who, again, they can be pretty useless as well. Often they have really poor record keeping. And yes, as building managers, they don't often have drawings for older buildings. They could give you drawings that aren't accurate. Another method is to go through council. Often council has records of previous building permits and drawings that you can go through and usually pay a nominal fee of a few $100s, and they can sometimes have those drawings, which will help inform your design. But otherwise, if you don't have those drawings, you've got to do a lot of investigation work, which again is time and costs. So yeah, I'd say yeah, it probably took us about 2-3 months from when we were first engaged to actually being able to getting all the right information from the body corporate and understanding the client's vision as well. So yeah, it took a long time, but the actual design itself, once you got all the information, is quite fast.
All right. Yeah, cool. It's all the human factor, isn't it? Yeah.
Yes.
Yeah. All right. Do we have any questions from the audience? See? Please don't be shy. Even if you have any comments or feedback, we would love to hear from you as well.
That's okay. No stress if no one's got any questions. I think Ati will send around the slides. There's some links in the slides that will be a lot more useful than me just running through a quick design for each calculator. Talks about the functionality of each calculator and yeah, the real benefits of them. I didn't use ClearCalcs previously. But yes, ever since I've been using it, it's really helped streamline our design process for members, members and connections in sort of residential buildings and light commercial buildings as well. Yeah, it just provides a feature for us to check our designs as well. We do use a range of software and for the design procedure, and so ClearCalcs it's another checking mechanism for us to verify the design.
All right. Thank you, Kyle. And we will try to have more of these projects walkthrough webinar in the future as well, as we have more projects to showcase with everyone. So if there are no more questions, I'm happy to give back everyone 20 minutes of your time. You will receive a copy of this presentation and the recording as well. And then if you would like a certificate for the webinar, just make sure to complete the short survey at the end of this. It will just pop up when the Zoom meeting ends. All right, on that note, thank you everyone for attending, and thank you, Kyle, for your time. Sebastian, you're welcome. Thank you for that. We would love to see you again next time. If you have any ideas for future topics, make sure you include that in the survey as well. All right. Thank you. I will see you next time.